Hi, Craig Uranic here, and I want to introduce you to section 7.2, Graphing Quadratic Functions in Standard Form. First, I'm going to start out showing you that the general formula for a quadratic is y equals some number, which we'll call a, times x squared, plus some number, we'll call it b, times x, plus a constant, or c. We're going to find out as we graph these that A, B, and C give us specific information. Just like when we were doing exponential functions in the form of A times B to the X, the A gave us special meaning on how to graph it, as did the B. This was the y-intercept, this was the base multiplier, as well as the general form for a line or a linear equation. Notice that we wrote it this way. The M gave us specific information, and the B gave us specific information, namely the y-intercept and the slope. So, here we go. First of all, I want to show you that whenever you graph a quadratic in this form, it is basically going to look like a comet with a tail. And so it will either, and I'm not a great artist, but it will either have a nice smooth shape like this, or instead of going up like this, it will have a nice smooth shape like this. So, to introduce this animal, let's go ahead and work example 2 from your book. Example 2 is asking us to graph a quadratic function, specifically sketch a graph of that equation there. In the past, you've always been told that probably the easiest way to start something like that is to get a table of values, find out what they are, plot them, and then take a look at the graph. Well, let's do that, but instead of doing it by hand, it's easier with your calculator. So rather than use that table there, let's go ahead and bring this in. The first thing we would need to do is put the equation in. So we have x squared, so we need this caret squared, minus, it's not negative, it's minus 4x, so 4, I like to put the times, I do not believe it's required, times x plus 7. There's our equation. Let's go ahead and use table to find a table of values. So we will do second graph, which is really second table, and we'll put the values in. Let's use, I'm going to just delete all of these. Let's go ahead and start with -1. You do have to use the negative sign. So we'll put -1 in. Let's do 0, 1, 2, 3. That ought to be enough. Okay, so there's our points. So I'll place that right here. Let's go ahead and plot those. -1, 12. So -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Puts us clear up here. 0, 7. Notice that 0 is always going to be the y-intercept. 1, 4. 2, 3. And 3, 4. Out of curiosity, let's go ahead and enter another number. Let's enter 4. And I want you to see that you have a mirror image going on here. With 4 we get 7. So 4 and then 7, which is what the y-intercept is. So you should be able to guess when I put 5 in what I would get. If you guess 12, that's correct. With a parabola, which is the name of the graph of a quadratic function, with a parabola, we're going to notice some properties, but let's go ahead and sketch it first. Again, it's going to be a gentle curve. It's going to look like a comet with a tail. It doesn't go to a point. It's a rounded spot here, but I'm not the greatest artist. Let's take a look at a few characteristics of this parabola, or the graphing of the quadratic equation. Notice that there are points that are equal distance from this vertex. And at the vertex, it creates something called a line or an axis of symmetry. When something's symmetrical, it looks the same on both sides. It's kind of like looking at your reflection in a mirror. And so the vertex here, and again this is called the vertex, around the vertex is something called this axis of symmetry. In other words, once I knew this point, I really didn't have to find this point. I knew that one away from this, straight across, is going to be the next point. Same thing with this point. This is 2 away from the line of symmetry. Go 2 more, and that will be a point on the parabola. So let me redo this problem a shorter way. The steps we're going to take to graph quadratics from here on out will be much easier. Let me tell you what the steps are going to be. Number 1, we notice the vertex is a very important point. It is either the minimum or maximum value, the smallest or largest value. It also shows us that there's a line there, so that if I find 1 point, I automatically have 2 points. So step 1 is we're going to have to learn how to find the vertex. Step 2 is once we have the vertex, an easy point is always to get the y-intercept. You should know by now that to find the y-intercept, you always set x equal to 0. So the next step will be to find the y-intercept. Once we find the y-intercept, then it's easy to find what I'll call the cousin or the brother of it because of this characteristic of symmetry. And then the last thing we'll do is we'll get 1 additional point. So we'll just, if this was our y-intercept, this was our vertex, we just find a point in between, maybe like an x value of 1, and find out what the y is, and then find its match across the line of symmetry. So then there will be 1 additional point. In total, I want you to be graphing using 5 points. Again, the vertex, y-intercept, and its corresponding match, and the other point you select. So let's get started. Step 1 is to find the vertex. Again, we said that the general form of a quadratic is f of x equals a times x squared plus bx plus c. We also said that they have special meanings. Well, in this equation you can see that the a of this equation is 1 because there's implied that there's a 1 in front of the x squared. The b is equal to -4 and the c is equal to 7. Turns out that the vertex can be found, the x part of the vertex can be found with the opposite of b over 2a. So that's a formula you're going to want to remember. Opposite of b over 2a. Again, you can see that b is equal to -4 and that a is equal to 1 in our equation. So therefore, the x value of the vertex is equal to the opposite of -4, which is +4, but I will go ahead and put it in so you can see it. And then a times 2 would be 2, but I will go ahead and substitute that in. So we get 4 halves, which is 2. Now, that's the x part of the vertex. How do you find the y part? Simply plug it in. So we find out what g of 2 is. We plug it in. 2 squared would be 4. -4 times 2 is -8. So in other words, we get -8 plus 7. So the vertex is x equals 2, y equals 4 plus 7 is 11 minus 8 is 3. So the point 2, 3 is the vertex. We knew that before, notice, when we grabbed our table of values. But now we have that special information. Now, once you get the vertex, the next step was to find the y-intercept. So let's do that. So we found that the vertex formula was this. We found out that it is the point 2, 3 because when we plugged in 2, we received the y value of 3. Next is the y-intercept. To find that, we set x equal to 0. Here was our original equation. If we set x equal to 0, that makes 0 here, so we're just left with 7. So in other words, this c has a very special characteristic as well. It is the y-intercept. So the y-intercept is the point 0 for x, 7 for the y. So if you had a general formula, you could say that in a quadratic, the y-intercept is always 0 and then whatever the c is. So now we have 2 points, and we'll be able to find the mirror image of this. And the final step is simply to get an additional point. Since we have a point for 0, we have a point for 2, I would just plug in the number 1 and get an additional point. So the third point, we'll plug in a 1 into this equation. So g of 1 is equal to 1 squared, which is 1, minus 4, because negative 4 times 1 is negative 4, plus 7. Well, that means g of 1 is equal to 1 plus 7 is 8, minus 4 is 4. That means the point 1, 4 is also on the parabola. So for example 2, we found these 3 points. We found the vertex at the point 2, 3. We found out that the vertex is a very special point because it gives us something called the axis of symmetry, which will allow us to identify other points. Then we would plot the y-intercept, 0, 7, 3, 4, 5, 6, 7. We can plot a second point because we know that there's a twin on the other side just of the line of symmetry, just 2 away. So that would be this point here. We found an additional point, the point 1, 4. And again, the line of symmetry allows us to find that fifth point. We have 5 points. Now we can graph the curve. Again, it does need to be not pointed, but it needs to look like a comet with a tail. It is curved. It does come down to a least part. It looks a little pointy from what I have, but do your best to make it look like a nice smooth curve. So there's the steps we're going to use to graph quadratics, and once you graph them, they are then called parabolas. So the graph is the parabola, the equation is called a quadratic equation.